Welcome back to Smart Geometry. Today we are starting our chapter 4 on transformations. Our first part of transformations is reflection. So what exactly is reflections? Good question, y'all. So reflections is a flip over a certain line that's given to you by direction. So that line, we call that a line of reflection. Everything will go perpendicular across that line. So for example, this point will go perpendicular. So if I were to connect these 2 points right here, it will make a right angle with my line of reflection. Same thing with the other points. They should make an exact same copy. So they're going over that line. Now, most of your lines aren't necessarily diagonal. Lots of them will give you some sort of direction. Most of them will be horizontal or vertical, like these 2 given lines. So let's kind of look at this particular list. When we are looking at a vertical line, we say, hey, what is the coordinate of that vertical line? And we talked about that when we talked about vertical lines in the last chapter. Vertical lines have a value, have an equation. They're x equals, and they're x equals wherever they cross over the x-axis. In this case, it's at 1, 2, 3, 4, 5, 6, -6. So the equation for this particular line says x equals -6. So when you're doing the homework, it'll say, hey, reflect this image over the x equals -6 line. So they're telling you that's where your vertical line's at. Not all of them will be over the axes. So let's kind of look at this first one. When you're looking at reflection, you're going to do a complete flip of each one. So we'll call this A, B, and C. There's no true science to this. We are literally going to just plot the points and say, hey, there's your line. So for example, point C is 1 unit to the right. So our new value will be 1 unit to the left, and we call that C prime. So all these will have a little apostrophe. That apostrophe means this is a transform image. So for example, B right here is 1, 2, 3, 4 units to the left. So then B prime will be 1, 2, 3, 4 units to the right. B prime. And as well as A up here, it is 4 units to the left, so we'll go 4 units to the right. 1, 2, 3, 4 units to the right. And that's your A prime. So now we play a little game of connect the dots. Let's see what that looks like here. So we go from C to A, B to C, and then A down. There you go. Should look exactly the same as the other one, just flipped over the line. So even though part of the equation is over across the line, it should go over on the other side as well for your primes. Looking at this other one down here, it does the same thing. So as we did this vertical line right here, everything's perpendicular to that, at least the connection between them. We go perpendicular across. Here on those horizontal lines, these have an equation of y equals. So y equals where it crosses on the y-axis. In this case, it's at 1, 2, 3, 4, -4. So these are the equations for your horizontal lines. So it'll be y equals. So same thing right here is this particular, we'll call this one A, this one B, and this one C. And 1, 2, 3, 4, 5, 6 units it's 6 units up above the line of reflection. So our A prime will be 6 units below the line of reflection. 1, 2, 3, 4, 5, 6. It doesn't necessarily matter the distance from the axes as much as the distance from the line of reflection. Same thing with 3. I mean B right here. B is 3 units down, so we'll go 3 units up. That's your B prime, A prime, and then C prime will be 3 units above the line of reflection, directly above C. You play the game, it will connect the dots here, and there is your triangle, a reflective version of itself. Now, we do have equations when they're reflecting over the x-axis and y-axis. As you see right here, when we look at our x-axis reflections, it is going up and down. X-axis will move things up and down. So the x value are not changed, are not affected, but the y value is. We will negate whatever the y value is. So in our case, these are all positive coordinates right now. So we got the coordinate 1, 1. We'll say that's A. This up here is B, and this down here is C. So the A value is 1, 1. And B value, it's at 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 6. And then C is at 6, 1. 6, 1. So when we reflect our image over the line, we will negate the value of y. So A prime will be at 1, -1. B prime will be at 7, -6. And C prime here will be at 6, -1. So when we go and plot this, we'll say, all right, so 1, -1, there's my A prime. 7, -6, 1, 2, 3, 4, 5, 6 right there, -6, that's our B prime. And then C prime will be at 6, -1. C prime. And then we play the games and connect the dots. And there you go. There's your triangle reflected over the x-axis. So let's look at the y-axis. We're going to do 2 because there's so many individual dots here. So when we're going side to side, what's changing? Is it my x value or y value? It's my x value. Those are changing. So in the same manner as the x-axis, we will only negate one of them. In this case, we're negating the x value because it's going across. It doesn't go up or down, so that's why the y value stays as it is, but the x value does change. So for example, right here, we got the coordinate 2, 3, and then this one right here will be 2, no, not 2, 3, that's 3, 2. Sorry, I got that wrong. It'd be like that sometimes. All right, we are at 3, 2. This value right here is a 2, 1, 2, 3, 4, 5, 6, 2, comma 6. We'll just use those two. So when we're reflecting over the y-axis, we're having a negative 3, 2, and a negative 2, 6. So when we plot this, we go 1, 2, 3, 1, 2 right there. There's your first reflection right there. And the second one will go 2, negative 6 right there. It's reflected over the x-axis. So these two quote-unquote equations, they're not really equations, but we just use them as directions of how to do this reflection. Now, let's look at this last one. This is the last one that kind of has some version of that as well. Any kind of y equals x. So the y equals x is a special line. We call this a one-to-one line because for every value x, the value of y is exactly the same. 2, 2, 3, 3, 4, 4, 5, 5. This is what we call also our parent function when we're looking at this as an equation, y equals x. Every other version of manipulation of a line of slope is based off this particular line. But that's a concept for a different day. Let's look at this right here. So we got 3 coordinates right here, there, and there. As you can see right here, if all your points are in quadrant 1, they'll stay in quadrant 1 when they reflect it. They just be above it or below it. But when they're in quadrant 3, they will go directly across. Quadrant 2, they go directly across to quadrant 4, and then 3 stays within 3, and 1 stays within 1. So we'll look at this right here. We got the coordinates 2, 1. For this first one, 2, 3, 4, 5, 5, 3, comma 3, 5, 3, and then 5, 6, 7, 8, 8, 3. So those are your 3 coordinates. We'll call this A, B, and C. So we got A, B, and C. We're going to reflect it over the y equals x line. So when we do that, all we're going to do is just switch the positions of the numbers of the art. So A prime will be at 1, 2. B prime will be at 3, 5. And C prime will be at 3, 8. So let's kind of graph that right there. So we got 1, 2. Okay, there's the first one. Okay, 3, 5. 5, 1, 2, 3, 4, 5. And then 3, 8. 6, 7, 8. And there you go. There is your reflected line right there. All right, y'all. Hopefully that helps out. And have a great rest of your day. Bye.